So this is going to be a fun session because we're going to do some crazy stuff. So I hope that people are still following along on the hands-on because that's where we're going to start for this one. So in this session, these are the topics. We're going to show you what a typical SEBA development loop could look like. And we're actually going to go through the steps ourselves. We're going to see how we test functionality end-to-end in SEBA, and also how we do other tests like system scale tests. And then the last 30 minutes of this session, we're going to talk about the roadmap for SEBA in the future, like what are the next steps. So I think everybody's going to be interested in that. So here's kind of the high-level outline for the development loop. Let me just go over this, and then we're going to switch gears into the hands-on lab. So the development loop is the developer makes some changes to the source of one of the SEBA components. Maybe it's a XOS service. Maybe it's Volta or an ONOS app. And then after the change is made, unit tests are run. And they should pass, of course. Then if in this case, in the case that we're going to see, which we're going to be changing an XOS service, we're actually going to change the AT&T workflow driver service that we've been talking about all day. We're going to build a new container image for that component with a new source in there. And we're going to deploy it on a running SEBA-in-a-Box. So I'll show you how to upgrade a running component in SEBA. Then we're going to run some tests, make sure that the new component passes the integration end-to-end tests that we have. And that's it. So lab number 4, we're going to walk through this process. All right. So let me switch back to the guide and find lab 4. All right, I'm going to need to go get my water, and I drank my water. Never mind. I'm good. Okay. So the first step in the hands-on lab, before we do anything else, we're going to reset the workflow to an initial state. And because we've been doing so many labs, I don't know exactly what state things are in. Let's do this. And so here's a little developer trick, a command that you can run to reset the workflow. I'm just going to cut and paste this. So what we're doing is disabling the ONU device, setting its admin state to disabled. OK, that worked. And so now let's take a look at the ONU device that we just disabled. Oops. OK, and we see it's enabled. That's strange. What happened? So this is just a little kind of developer. It's not a backdoor, really, because it's part of that big flow chart that you saw earlier for the AT&T workflow driver. But what happened is we set the state of the ONU device to disabled, and then this triggered the AT&T workflow driver. And the AT&T workflow driver took a look at that ONU device and said, I have a whitelist entry. The ONU has the right serial number. It's in the right place. I don't see anything wrong. It should be enabled. And so based on the policy in the workflow driver, it flipped it back to enabled. But the nice thing about this is if you look at that big workflow, that flow chart, when this happens, the subscriber is also reinitialized. Because if the ONU gets disabled, we want to force the subscriber to re-authenticate. And so let's just make sure that that actually happened. We'll look at the AT&T workflow driver service instance. And so we're back in the initial state. ONU has been validated. We're awaiting authentication. So that's good. So the next thing is I'm going to show you how to run an automated test. You don't need to maybe do this step. It takes 5 minutes. If you do it, it's fine. But in the interest of time, I was just going to do it and then move on. Before I or anybody does this, for some reason the guide was modified and there's a command missing, which is down here in step 6. I need to run this command to make a tiny change in the makefile that launches the test so it works based on the way we've manually set up SEBA-in-a-Box. Because it sort of assumes you set it up using the makefile, and it gets unhappy if you did it some other way. So now I'm going to go back to the test and kick this off. So I'm going to run a make command using the makefile that's in this directory, Core Automation Tools SEBA-in-a-Box. You could also use this makefile to set up SEBA-in-a-Box. I think I mentioned that earlier. We didn't do that, but it's a nice, easy way to get things working. All right, so it sets up a virtual environment in Python to use to run the tests, load some stuff in there, and then it's going to start running the tests. And then in a little while, maybe a few minutes, we're going to see this summary of what tests passed. In this command that I ran, I told it this test tags equals test 1. I told it just to run the first test. There's a big test suite. It takes a long time to run. We're just going to run the first one. This is basically just the authenticate the ONU, do DHCP, run the ping. It's basically that same test. So that's cranking away right now. So in the meantime, I guess I need another window to do this. Let me grab another window. Another tab. SSH into my node. Oops, I don't have history, I guess. That stinks. What's my node? Node 39, SEBA tutorial, Core test drive, Utah Cloud Lab. I'm doing this from memory. I'll probably got something wrong. Okay, that didn't work. Let me look at the spreadsheet. Okay, I forgot PG0. Right. All right. So how are we doing? That's still running. Let's go back to the lab. All right. So the next step is there's a patch in Garrett, which is our source code reviewing system that I've set up for using in this lab. We can actually click on this and see what a patch set in Garrett looks like. Make this a little bigger. So this is the patch for the SEBA tutorial, and you can see over here where it says project, the project is AT&T Workflow Driver. That's what we're going to be patching. And here is the source file listed down here that the patch has been made to. So, and we can even look at this. So what you'll see is that, so this is the old file and the new file over here. So what I've done is changed the message that the workflow driver displays when authentication succeeds from authentication succeeded to hi ONF connect. So that's the patch. So we're going to download this into our source tree. So you might do this, in your regular development cycle. You might do this because somebody else has submitted a patch and it doesn't look quite right, and you want to try it out to see if it works or if there's something wrong with it. Okay, so we got the patch. Next, the next step is we want to run the unit tests for the AT&T workflow driver on the patch. And I'm going to kick that off. Let's go back and check on my other test. Okay, that's still churning away. It probably takes 4 or 5 minutes to run this first test, including like setting up the environment and the other pieces that it had to do. Okay, so some things still happening over here. I guess it's setting up the test environment. I'm hoping that it makes some more progress in a minute. If it doesn't, I think we'll just exit out of there. And okay, good. Here we go. Now it's running a bunch of tests. Okay, it ran the tests, and okay, everything passed. Congratulations, we did it. So this patch we downloaded seems okay so far, passes the unit tests. But the next step is let's actually load it into SEBA-in-a-Box and see if it works. So the first step in this, so we're running, all of the SEBA services are running as pods in Kubernetes, which is built on top of Docker. So we need to build a new Docker image with the modified source code in it. And so here's how we're going to do it. Now, we need to be in the same source directory, this one down here, for the AT&T workflow driver. We need to build the container in there. So we run this make docker build command. Let me go back and check on my end-to-end test. Okay, so the end-to-end test has now passed. So I only ran one test. It passed. So that's good. That part succeeded. Over here, in this window, we're waiting for the container to build. So the first time you run the container build, it takes a little while, maybe a minute or two. The second time you do it, and subsequent times, it'll go much faster because Docker is really smart about caching. It can reuse the pieces that didn't change. And so subsequent builds are much faster. In fact, let's see. I'm going to just build it again really quick. And it's already done because it was able to reuse the cached version. OK, so we have this new container. And here's the name. XOS project AT&T workflow driver synchronizer with a tag of candidate. And this is the one that we want to try. So now in step 5, we're going to replace the running AT&T workflow driver with this new version. So the image, since we built it on the same machine running SEBA-in-a-Box, it's already there in the local Docker registry on the machine. All the images that Docker knows about, it's already there. It's also possible to use different models. So for instance, you can build on your laptop and push the images to a separate machine running SEBA-in-a-Box. There's a page, it's linked there, linked right here, that describes that process in a little more detail but we're taking the simple method right now. Okay, so in order to upgrade the running AT&T Workflow Driver service, there's this magic command that we're going to run. Before I run it, let me just show you the important pieces of it. So we're going to run Helm upgrade AT&T Workflow chart. Here's the original chart that we used. Here's the original values file that we used when deploying that chart. But now there's a couple of new things. We're going to override some of the default values from the charts. We're going to set the AT&T Workflow Driver image tag to candidate, because that's the new one we built. And we're also going to set the AT&T Workflow Driver image pull policy to never. So with the candidate is the image we built. This pull policy equals never means we already have the image. We don't want to go out to Docker Hub and pull the image down because it should already be there. So let's run this. Okay. So we see some output. So I walked you through that upgrade command, and that is redeploying the image. This, I'm not going to go through it, but in order to know how to make that command, in particular those different variables that we overrode with the set command, we need to understand something about the way the charts are structured. Like I said, I'm not going to maybe go through this right now, but there's an explanation here in the document about how to go through the structure of the charts and figure out how to override particular images. So you can read that on your own if you're interested. Okay, so this command, let's verify that SEBA is actually running the new container. So this is going to, this command is going to look at the pods that are labeled with the AT&T Workflow Driver label. It's going to look for them ones that are running and print out their names, and then it's going to look in detail at what's going on in those pods. And it's going to grep for the image. So this is just a long command to extract the image that's running. And we can see that the image is the one that we built, with the one with the candidate tag. I should have showed you which one was running before we did these steps, but I forgot. But it wasn't that one. Okay, so now what we can do is run the same test that we ran before, or that I ran before and you saw me run, on the new container, on SEBA-in-a-Box running the new container. So if you want to do this yourself, first you need to run this magic sed command. I've already run it, so I don't need to do that. And then we're going to run the tests again. And again, this takes maybe 4 or 5 minutes to complete. Maybe while we are waiting for this to complete, as you can see from the lab manual, it's actually going to fail. So we want to make life a little bit more interesting. Maybe while we're waiting, I can stop here and ask if there's any questions about this. So I know just in general today, so I've been talking to people at the breaks, just in general, there's been a lot of information covered both in the slides and in the hands-on. It's been going very fast. The point of the hands-on exercise hasn't really been to help you understand in depth like all of the pieces of SEBA and how you might need to develop individual pieces like the Helm charts or the services or whatever, just to kind of show you at a high level a set of commands that people use daily to develop SEBA or deploy SEBA. And so just so you've seen it. And hopefully you've seen enough that it looks interesting to you and you want more information. And then the place to go to get that information is the online guide at OpenCore, guide.opencore.org, that has a lot more information about how to, say, configure the Tosca for a production pod, how to set up your OLT hardware with the right OpenFlow agent package, OpenOLT agent package, or all of the steps that you would need to actually build up a production pod and deploy it. So this today has just been, let's just go through it quick. You've seen it. Now maybe you'll go and do a little bit more research on your own. Okay, that said, any questions while we're waiting for this test to fail? It looks like it's almost failing. So green dots, when it prints green dots, that's good. When it prints a big red F, as you can imagine, that's bad. So I think this should be done in just a sec. Oftentimes when I'm developing and I see a big red F, I'll just hit Control-C to exit out of things. But if you do that, then you lose the ability to go back and look at all of the test output that Robot Framework puts out, because I think it aborts before it prints out the extensive logs that it does. And so that's why we're waiting for things to conclude here. All right, so our test failed. That's good. So seems like there's something wrong with our patch. And so let's look at how you could start going about figuring out what went wrong by looking in more detail at the test output. So Kailash is going to come up in just a minute and talk more about the test framework, but it's using Robot Framework, and it's writing logs in this particular directory here. These logs are best viewed in a web browser. So what we're going to do is use Python to run a simple web server on a port in that directory so that we can then point our browser at it and check out the output. So let me run that. And so now I need to point the browser at it. Let's see. I think we're done with Grafana, so I'll just use this. All right. And here we are, looking at the robot output.
From the test that Andy has run, from the console output here from the test, you see that the test generated 3 report files. And so that's what we'll inspect first on why the test failed and how to debug failures. So we go into the report.html file here, and we see that we only ran 1 test here, and that was test 1. That's how Andy had ran the test. So we go into test 1, and we take a look at, this is the test case that was run, and it said it failed here. So we can go inside this test case itself and actually see where and why this test case failed with some verbose output. And it can get even more. This is just the basic information log level set to info. But if you want things like the actual traceback and more debugging output, you can definitely set that in the robot parameters. So here we see here that the test case failed at the step of subscriber chain created, subscriber service chain created. So as you guys now know about how all the NEM services are tied together and talk to different components of the SEBA platform, there's multiple levels of testing you need to do for SEBA. So one of the steps that we do is before we try to authenticate the ONU, we validate some of the states, some of the data model states, at least the relative ones that we actually care for. So in this case, the AT&T Workflow Service Instance, which is the model that we've been inspecting all day after we've brought up SEBA-in-a-Box. And so this service instance contains information about the ONU. And so the check that it does here is that it validates that the state of the AT&T Workflow Service Instance is in ONU has been validated and authentication succeeded. This would be post sending an authentication request, in which we see above here it actually did do that. So in here, the test actually went into the RG and executed an authentication command, and you see that it passed. Now, after it passed, there's validation steps we need to do across the different data models in NEM. So one of them is the AT&T Workflow Service Instance, and we're checking for the states here to be an enabled, approved, and also the status message of that service instance, and we want it to say specifically ONU has been validated and authentication succeed. And over here, the test actually failed because that's not what that string said. Instead it said ONU has been validated, hi ONF connect. And so the test is expecting a different string, and that is all because of the patch that Andy downloaded and built the container on that patch and used that patch to test the system. So that's just a very simple way to debug testing failures using the robot files and the robot framework. So now I'm going to go back to the slides here.
So I just wanted to say, so that's kind of a stupid failure, just because it's not really a failure of the system. It's just changing a message. But hopefully it illustrated two things. One, that we actually did load the patched code into the system and ran the tests, and we saw that the code had actually changed. So that's the first thing. And then the second thing is that when that happens, we can dig down into the output produced by this framework and get more information about exactly where the failure happened in the test suite. And we are only running a single test. There's many more that test all sorts of different aspects of the end-to-end behavior of the system. Thanks.
Yep, correct. All right, so let me go over the core tester framework. So the core tester framework is an automation test framework written in Robot Framework and Python. So Robot Framework is an open source test automation tool. It's built on top of Python. It also integrates well with Python and Java, actually, so you can write test functions and test libraries in Python and Java. It's application independent, so whatever your device under test is, it doesn't really matter. So it's a really good tool used to do black box and somewhat of a gray box testing of your platform. So our core tester framework, we have various test suites to validate functionality, regression, and stability of various components of Chord. Now, what Chord tester is not is it's not a testing framework to test individual components and system tests for those individual components, such as ONOS and Volta. So as you guys know, those are big components of the SEBA platform. Chord tester, there are not test suites inside Chord tester to thoroughly test those applications and those platforms. But rather, it's more of a test framework to validate the full system end-to-end stability, functionality, and regression of the end-to-end SEBA platform itself. So this core tester has, so the framework, we have shared libraries between multiple test suites. and mainly around physical pods and SEBA-in-a-Box. So, you guys have all just deployed SEBA-in-a-Box. So that environment itself is different from what a physical environment looks. Now the components and how the end-to-end behavior is very similar. However, the topology of that is different, obviously, when you have physical hardware and physical devices. But within the core tester framework itself, we have various different test suites for different devices under test and different platforms under test. But there are many shared libraries between them. So these libraries and these tests have been written over time. So for people wanting to contribute or helping out with the test infrastructure as well too, there's a lot of good functionality and libraries there that you guys can pick up and get going. So the current end-to-end test suites are based on the AT&T workflow, so the service that we've deployed today and what we've been inspecting today. So an example of a SEBA test with the current framework involves configuring the pod. So configuring the system, when we deployed SEBA-in-a-Box this morning, we pushed a number of Tosca recipes to configure our SEBA-in-a-Box. So in the physical environment and the physical pod, we have our own set of Tosca recipes that will configure specific pods. So we have a number of physical pods, but each pod is different in terms of where the PON ports are plugged into, how many OLTs are connected to it, how many ONUs, and how many subscribers are actually connected to the device, and also information such as the CNS tags of the subscribers that you want to configure. So that's all. So each pod itself will have its own Tosca recipes. And also in our test framework, we have deployment configs. So that will hold information as part of your specific deployment. So depending on the pod, the test framework itself, the tests need to know what pod is under test. So it needs to know things like the IPs of the nodes. It needs to know where the Kubernetes configuration file, which Kubernetes configuration file to use, because the test does interact with Kubernetes as well too, to do things such as debugging and inspecting some of the pods and services. It also needs to know the CNS tags that you are trying to provision, so things like that. So each pod itself has its own deployment config as well. So what the test, kind of the flow of the test, a simple test case, which is the one that we just ran right now, what happens in that is we first start off the test case. So post-deployment of of SEBA and your pod, whether it's SEBA-in-a-Box or this whole pod in a physical environment as well too, post-deployment and the beginning of the test, what the test does is it validates the initial states of each of the data models, as well as validating certain steps, certain things in Volta and ONAS as well too, just to make sure that the environment is set up and ready to authenticate and get a DHCP address and in the end do a ping. So there's functions in there that check the NEM data models and also check and make sure that the devices are alive in ONAS and the device and the logical device representation is also there in Volta. Now once that's all done, then we get to the authentication step. So the test will physically log into the subscriber and send an authentication request via the WPA supplicant command. The test will also validate the output of that command, and then it will validate the NEM states. So as you guys see, that the NEM states will change once you authenticate a subscriber. It'll say, authentication succeeded. So we validate that. So once we know that the authentication validated, then we will go back to that RG or subscriber and execute a DH client command, which will tell the client to go out to the DHCP server and obtain an IP address. Once that command successfully returns, we validate that an IP address has been assigned on that interface. And then we, again, validate the NEM states, making sure that DHCP has succeeded. And then we go back to the RG again and send a ping request and validate those ping requests. So that's an end-to-end test. And so once that happens, we call that a success. And so the current SEBA test, this is what kind of the framework involves. So on the right here, these are the inputs, and this is what drives the test and the behavior of the test. So the tests actually use REST APIs. In some tests, we also do upload Tosca recipes to easily configure the pod. But in some of the tests, because they're focused on feature testing and certain behavioral testing as well too, we just use REST APIs. We also use, we have the libraries to interact with the ONAS CLI and as well as Volta CLI for debugging those systems as well too, and validating certain states in those components as well. There's input configuration files, and then there's common utilities for these different components and software components. And that's what the test, those are the modules of the test. And then the main components that we test in a SEBA pod are NEM, ONAS, Volta, and the aggregation switch. So the test will actually talk to each of these components and validate at each of those layers of what the end state should be. So here is an example of a successful test run for the test case number 1 that we just ran that actually failed because we pulled in a wrong patch. So if you look in here, this is a SEBA-in-a-Box test case. And if you look in here, I'm not sure if you guys can actually read those, but if you go through the flow of these steps and these commands, the first keyword here, you guys will see here, subscriber ready to authenticate. So it checks and validates states in NEM and checks for these states, awaiting authentication, validates the subscriber status. And then once that's done, then we know that we're ready to send an authentication request. So this command right here will actually send an authentication request from the RG. And then after that, we validate that the subscriber service chain has been created. So we go back to NEM, validate that the states of NEM changed. And then this is when we get into ONAS, and we validate that the cross connect inside ONAS for that subscriber has been created. Once that has been created, then we know we're ready to execute a DHCP command and also ping. And so these keywords and functions are actually used by various test suites. So that's why they're heavily parameterized here. If you read and look into the documentation of the test cases itself and the test libraries, you will be able to follow what this command exactly does. So in here, we want the pings to be true and passing, and these are all the parameters that you give it for this specific test. And so once the pings pass, then we're going to do another test in this test case itself too, and we're going to disable the subscriber. And then we validate that the subscriber actually got disabled and that the cross-connect inside ONAS itself also got removed. And then we validate that pings will fail. So that's all good, and that's fine. And then here we reset the subscriber. So earlier what Andy had done was he reset the subscriber. Well, he actually reset the AT&T Workflow Service instance. But in this case, since we are testing the whole subscriber chain itself, we're going to reset the subscriber. And we're going to tell the subscriber, you're back into a waiting auth. And because we want it to re-authenticate itself. Once a subscriber gets deleted by the AT&T Workflow's business logic, if it's disabled, we want it to go through the same process again and re-authenticating itself if it ever gets disabled for any particular reason. So we reset the subscriber itself here. We re-authenticate. We check that the subscriber service chain got created again. And then we make sure that pings are passing again. So that's just one example of how the flow of the test case, they're very behavioral driven, and we need to test it from the operator level. So a lot of these functions and orchestrating the test and the functionality of SEBA itself and these services are happening at the NEM layer. But you can see that it's also touching and inspecting different components of the platform itself too. So it's not a simple appliance as, let's say, look, we have a service here, XOS and AT&T Workflow Service inside XOS and NEM. We can't just test that service itself. The only thing we can test in there is, create a subscriber and validate, or create an AT&T Workflow service instance, or create an AT&T whitelist and validate that that whitelist was created. That's to the extent we can test XOS. So testing the whole platform itself involves all of testing and inspecting all these various components of SEBA itself, and in the end, doing an end-to-end ping traffic testing. So these tests have been developed over time, and we've learned, and we have been constantly upgrading these tests and adding more and more checks to the system itself, particularly and mainly for debugging purposes, and also checking the point of failure of the test itself. Because if we were to just send authentication and DHCP and ping started failing, we don't know where and why the pings are failing. It could be that ONOS failed to push the flows to Volta, or that Volta failed to create the flows in the ONU devices. There can be many points of failures, and to inspect that and determine that, they could be different on different scenarios as well too. So this is how we have developed these test cases. It's an ongoing development, but this test case here will help us indicate, where the failures can be, whether it's inside NEM or inside ONOS, inside some ONOS apps, or inside Volta itself. So this test case, the test framework is designed to help determine the point of failure. And I want to quickly talk also about the test cleanup, because this is also very valuable to the test framework itself too. So at the end of each test case, the test cleanup here is called, and that's also part of the reason why the test case take long to run too, is because we want to make sure that we restore the state of the system back to its initial state, so that you can be ready to retest it again. So, and also there's a couple, the first 3 commands here are for debugging purposes. So in case things fail, like in the middle of the test, this function will always be called. And here you see get Volta status, get ONOS status, and log Kubernetes container logs since the beginning of this test case. So within this report itself, if you expand all of these keywords, you will get, inside Volta, you will get outputs of Volta CLI commands, such as logical devices, logical ports, and flows for each of those devices. Same thing in ONOS, you will get outputs of the flows and the ports, because those are very helpful to debug failures. Volta, for example, the failure, if the failure is in ONOS itself, you will be able to see that something probably didn't get pushed into Volta. So probably something happened in ONOS. ONOS failed to create a port for one of the devices. So that will help you look, and then after that, if you expand these logs too, this keyword will actually save all of the pod logs or the container logs, and you will be able to actually know exactly which service you need to look at and which logs you need to look at to debug. Because again, like I said, there can be many points of failure. So that's the first 3 keywords here in this cleanup step, and then after this, these are the steps here taken here to reset the environment. Actually, it actually will clean up all the objects. Actually, it'll clean up the whitelist. So then forcing the ONU to actually go into a disabled state and get reset. Hmm?
Sorry, but the log Kubernetes,
Mm-hmm.
do you specify the containers that you certain logs there, or everything will be enabled by default?
Yeah, so in the test framework itself, in this specific test, there is a list in the test setup that contains all the relevant services that you want to log. So when you deploy a Kubernetes, when you deploy a system under Kubernetes as well too, we obviously only care about the services that we are deploying, but Kubernetes itself, if you do a Kubernetes get pods -- all namespaces, it'll give you Kubernetes specific pods as well too, just to control the container management system. We don't care about those because that's Kubernetes specific, right? So in each of the test suites itself, we have a list of services that we actually care about and we want to debug. So
Are you exporting the logs of each container?
Yeah, it will get so the logs. So the command inside this keyword, I can probably actually pull it up here if I have a GUI here. Probably from. Give me 1 second. I can show you. Okay, Google Chrome. All right, so here, if we expand this, and we go log Kubernetes pods, container time. So here are the services that we care about for this particular test. AT&T Workflow Driver. So if you expand this here, right here, it will expand all the logs for this service, and you will be able to see here what's going on with this service. Now, the failure from this test itself wasn't really that relevant, but for example, if someone did introduce a bug within this service, you'll likely see an exception here, or something, a business logic failed or went a wrong path, and you'll be able to see it in these logs.
Are you going to be able, let's suppose the TCD wrong, if you have an exception or a problem with the container, you'll be checking here?
Yeah. So all of these logs are in the report file that's generated from when you run the test. So also, and these these pods, so the output for each of these container logs also will get reset at the beginning of each test case. So you pass in, this keyword will take in a timestamp. So you get that timestamp from the beginning of when you start your test. And Kubernetes has a command where you can pass in timestamps, or since time, if you see that argument here, since time. So Kubernetes will only give you logs from that time, from when you cared. So it's, yes, exactly. So each test case will have only a subset of the logs from when you actually started doing your testing.
All right.
Yeah.
Another question, do you have some tests to consume the logs or alarms on Kafka?
So we don't have any testing for Kafka or alarms itself. That is actually tested indirectly.
So right, let's suppose a new subscriber is authenticator, let's consume directly on Kafka.
Yeah, so if that model never got created, or if that model never got updated in XOS, you can look into Kafka and seeing why that message didn't come. This test suite itself, we haven't added that debugging in this testing because that kind of failure doesn't happen often. Or if it does, the test itself in the beginning will fail because that model actually would never be created. So our first debugging step itself would be going to ONOS and checking if the device is there, and if it's not there. Actually, a couple of folks in this room today, we saw this today as well too, where the Kafka event never got, ONOS never put the event on Kafka, and that's because ONOS actually started before Kafka started. So that event got missed. And so we had to debug that, and we recreated that device so that it sent a Kafka event as well too. So in that case, this test would have failed from the first step itself. Yeah. And so so as we find more and more areas where we find different points of failures, we would go back to this test suite and reevaluate it and determine, okay, let's add this to the debugging, or let's add this to the test cleanup, or if there's additional conditions we need to check for the test itself, we'll add it to the test setup. So that's kind of how the test looks.
I think your cleanup is only including the whitelist cleanup, and there's one more step at the end.
Yeah, so, yes. So in SEBA-in-a-Box itself, that is actually all you need to clean up is you delete the whitelist, and when you delete the whitelist, the ONU will go in the disabled state, and then, whitelist and the subscriber. And then you make sure that the subscriber service chain got removed, and then also the Fabric cross-connect got removed in ONOS. Now in test setup, so the way Robot works is if you also have a test setup, those functions will run at the beginning of each test case. So if I go back to the actual report, one of the logs here, let me pull up actually what the test setup looks like. And it basically recreates these models. So we can look at one of these test cases here. So here is the test cleanup at the end of test case 1, and here's the test setup at the beginning of test case 2. So as I mentioned to him before, we make sure we get the timestamp at the beginning of when we run the test, because we want to make sure we capture from that point forward. And then we create the subscriber, and we create the whitelist, and we validate that the subscriber is ready to authenticate again. And then we do the next test scenario. This is only SEBA-in-a-Box. So the test setup for a physical pod involves a lot more. And so that's why that test suite is different. So you can think of, in a physical pod itself, actually, we actually have a physical device connected to the ONU. So it's a physical server connected to the ONU. So when you clean up that system and when you send authentication requests and ping requests, you have to actually go into that system itself and create an interface, create a double VLAN tagged interface to send out packets from. And so the test cleanup involves going back to that server, which is our emulated RG. Well, it's not emulated, it's an actual RG, you can think of it. And clean up that interface, delete the IP address on it, and make it clean, make sure that there's no WPA supplicant processes running on it. Make sure we kill those processes, make sure we kill the DH client processes, and really clean and wipe out the system. And here, in this test suite itself, with PwnSim, all you need to do is restart the RG container, and that'll do it for you. Yeah, so that's why we have these common libraries and functions. In Robot, we call those keywords. So all these common keywords and functions are shared between different devices under test. So whether it's physical pod and SEBA-in-a-Box. So this is specific to SEBA-in-a-Box test. But the flow of it is similar to a physical pod test. However, some steps in terms of cleanup and setup are different in the physical pod. So yes, to answer your question, we do have different test suites for different environments. But most of the keywords and functions that these test suites use are shared amongst both environments. Yeah, so the current automation test suite that we have tests the functionality of the business logic that we support. And currently, we have an AT&T workflow, right? So the AT&T workflow has a specific business logic in terms of when an ONU is brought into the environment, the operator is supposed to create a whitelist for that ONU to make sure that it can come onto the system and get authenticated, right? So the business logic itself, there's also a logic there where, okay, we have to also test that what if an ONU gets recognized by the system, but the whitelist is not there? Try to authenticate it. Let's make sure that it doesn't get authenticated. Or there is a whitelist there, but it's on the incorrect port location. Then authentication should not succeed in that case. So we do all of those scenario-based testing in the automation test framework. Currently, we don't have. We also have automated tests for system upgrade and as well as some data plane failure test cases in terms of rebooting the aggregation switch or restarting the ONOS controller or restarting the Volta controller and making sure that those configurations and states get reapplied to the system and that we can continue to pass traffic. Now, things like if a fan goes out in a physical, in an OLT or even in an ag switch or something, that we don't have, those cases are not covered in the automation test suite.
You do the workflow testing.
Say that again?
You do the workflow testing.
Not necessarily. It's not just virtual testing. Workflow. Yes, workflow. So all the scenarios are driven by what the workflow is and the business logic is.
Okay, welcome to the last half hour of our tutorial. Hopefully it's been really good, really productive so far. In this last half hour, we're going to talk about what is coming next, okay? So we're going to talk a little bit about roadmap and highlight a couple of very exciting things that are happening on the SEBA Volta front, okay? So let's jump in. So
Um, at the last ONF Connect last year, which was around December timeframe, is exactly when we first did the first release of SEBA, right? It supported the high-speed internet access service. It used AT&T's workflow, which you have been looking at all day. It supported Volta 1.6, and it was on this new CORD software platform, which also you have been using today. Okay. A couple of months ago, we released the second version of SEBA, which is what you have been trying today. It included technology and speed profiles. That was really important to get that in because it was a big missing feature not to be able to specify per subscriber bandwidth or be able to bring up QoS in the PON. So that's a feature that came in. Still supported AT&T workflow, high-speed internet access service. It was on a version of Volta which had that support, and it used this Broadcom software that goes into the OLT that's called BAL. It supported BAL version 2.6. However, there were some issues, and that's why the SEBA release is called SEBA 2.0 alpha release. And at some point, we do expect to be able to upgrade to BAL 3.1 and be able to release that with the same features that SEBA 2.0 had, but without this alpha designation. But what I want to talk about is SEBA 3.0 and beyond. Yes, there's a question.
Curious, BAL is very vendor specific. The whole process is trying to be somewhat vendor agnostic and disaggregated.
That is true.
So why is BAL part of SEBA?
Okay, so the way it works is that ONF doesn't create products. It creates exemplar platforms, or it creates exemplar implementations. So ONF in itself, when it does a release like that, it chooses one thing, and it tries to create a reference implementation, and it hopes that other people pick it up. If they want to bring in new hardware, they bring it in. If they want to replace parts of the SEBA stack with their own proprietary versions, they can do that. And I'll talk about modularity in a second, okay? Sorry, not in a second, but in this session. But the idea is that we, as an ONF, when it puts out a release, it puts out something that works together. And we have to, as a result, make certain choices. This is the choice we made because this is the one which gave us the maximum control in putting out something that the world could use, anyone in the world could use, and not be stuck by saying, okay, now I have to go out and purchase something that is proprietary or get a bunch of licenses that I just want to try it out. And yes, with this approach, with these choices we made, we could create this reference platform. But it does not mean that you can't bring in other pieces, which I'll talk about when I talk about modularity. So as I was saying, in SEBA 3.0, that's the expectation that we have. Two things that will be coming out of that is Volta 2.x, which you will hear about in a second, the new version of Volta that the entire community as well as the ONF team is totally working on, dedicated and working on right now to bring Volta 2.x be able to harden it and make it ready for production deployments. So that's something that we are targeting for production. Then there is this other work that you will also hear about, which is, the BNG. So far, we've been referring it to being external to the SEBA pod, right? But we want to be able to do the same things, SDNize it, open it up, that we did with the OLT. We want to do that with the BNG as well. So we want to bring that functionality inside the SEBA pod. So there is some experimental work that we are doing that we'd like to talk about. That's also very exciting work. And then the Deutsche Telekom and Turk Telekom workflow. So far, you've been seeing the AT&T workflow, but there is work going on for both the DT as well as the TT workflows, and we hope to be able to bring that in and make it part of the release. Question? Yes? It is most likely the same software stack that you see in SEBA 2.0. That won't change, only the BAL part will change. Yeah, so it's going to be very likely Volta 1.7. It's just to get rid of this alpha designation. That's the way you should look at that one. And that just helps us out because then the community doesn't come back and asks us a million questions about something is working, something isn't working, why is it not working, and so on. So just be able to, so we don't expect to put in much more work into SEBA 2.1 other than the work we are doing to upgrade BAL. Yes?
And SEBA 3.0 is not going to include any functions other than these,
No, this is a, so the way to look at that is that, the work is really being going on to Volta 2.x. There is some experimental work that is going on in the embedded BNG. And then there is, at the same time, many features that are coming in for Deutsche Telekom and Turk Telekom workflows, right? So when those workflows become part of SEBA, then they automatically get released. When those, then they automatically bring in new features.
let me rephrase it.
Mhm.
The Tiger team's commitments, are they going to make it with SEBA?
So let me come to that. That's my next slide, okay? So, yes, question.
Regarding SEBA 3.0, we can expect the support of Deutsche Telekom and also Turk Telekom on NAM for their workflows, or they are not using the NAM?
No, so when we do that release, it will be just like you, so just like you were using AT&T workflow instances, there will be equivalent instances for that. Because that's the whole point of workflows. In a particular deployment, depending on who the operator is, you bring up a certain workflow and not the other workflows, right? So yes, there will be equivalent synchronizers and services in NEM for those workflows. Right. Question?
There is SEBA 3.0 and beyond.
Yes.
So I would guess Volta 2.x is SEBA 3.0, but embedded BNG is huge functionality.
Yes.
It's beyond.
Yes, so actually, if you notice, I haven't put any dates there.
Yes.
And the reason I haven't put any dates over here is that all our commitment right now is to Volta 2.x, okay? So I don't, there is a timeline for that part, okay? But when that makes it into SEBA and when we do a proper release, I'm not sure yet. And that's why there is no date. And that's why I just listed, the three most important things that I see. And your feedback is good about the embedded BNG having, so when we talk about that, you'll see that there are lots of incomplete functionality, but there are some things that we are working on.
How would you tackle this? Would you form a brigade for this embedded BNG or how?
It's not clear yet. We did put out a message for a brigade for people who wanted to work on it, but it was, we didn't get a lot of responses. So it's to be decided. We don't have a current brigade on this work. We wanted to discuss the work itself some more with the community, perhaps on the SEBA calls. And then down the road, we will make a call on how to, if we want to create a brigade or not.
Maybe I should reverse the question. Which operator is the most interested operator in embedded BNG?
Embedded BNG, which operator is the most interested? Well, let me tell you this. This is a preview of the work that Daniele will talk about. The embedded BNG work is inspired by prior work from Deutsche Telekom. Yes, Deutsche Telekom has already done a lot of this work. They, in fact, contributed that code to ONF open source repositories. And inspired from that work, we have started this work. So clearly, they're doing it. But I can also tell you that Turk Telekom is also very interested in that work. Okay? So let me move on. Lovely questions. I love it. But I do need to get beyond this first slide. So yeah, very quickly, I want to talk about SEBA modularity. You've seen in this tutorial all parts of these, right? There's Volta there, ONOS there, NAM, monitoring, orchestration, some backend stuff, apps, so on and so forth, and the physical hardware that is on the lowest level, right? So one way to think about this is that if you're using Volta with the physical hardware, right, the OLT and for the access part, Volta is not standalone software, right? Volta has to go with an SDN controller and the apps written on top of it. Okay, so that's one way to sort of box things, right? If you're using Volta, you must use ONOS, or you must use another SDN controller with similar functionality, right? You don't have to choose ONOS, but that's what it comes with right now. You can have your own SDN controller on it, okay? Another way to think about modularity is that the aggregation part, yes, today comes from Trellis, which is a project that Scott talked about in the very first session. But you can choose not to use it, right? You could choose to use another networking technology for the switch. In fact, it could even be a traditional networking switch, and that's perfectly fine. You just have to have a way to control it like we do to create the workflow for a particular operator. Yeah, slightly old slide, but that abstract OLT, basically, this was related to ONAP, which you may have heard of, is a global orchestration. So today in the SEBA exemplar, we have NEM as the northbound. So if you want to interact with the SEBA pod, you interact with NEM's northbound interfaces. So abstract OLT was sort of a local adapter, if you wish. Okay, it's a local adapter to take stuff that comes from, say, ONAP, and then and then adapt it to the calls that NEM expects. So it was a piece of software that actually came from AT&T, and the need for it may have actually gone away. It's just a slightly old slide. But think of, instead of saying abstract OLT, think of any local adaptation that you need from the NEM's northbound interfaces to interact with whatever operators or SSBSS systems there may be on the back end. In some cases, you may not even need that local adaptation. Maybe the OSS-BSS system can directly talk to NEM, okay? So let me continue to talk about modularity. I've sort of siloed these pieces, and I've said that, okay, yes, Trellis, you could replace it with other things. Another silo could be, okay, this is what we call the platform, right? And this is coming from, in the compute nodes, this is the operating system that we use, its version, the Kubernetes version that we use, the Kafka version we use. You could choose to use the ones that we have in the exemplar. You could choose to use different versions from the one we have in the exemplar. For example, AT&T will say that they want to use the ones that are in the Acreno project, and that's perfectly fine, right? As long as you ensure that the rest of the system can work with those newer versions, that's fine. You don't have to use Ubuntu as the operating system in your compute nodes or the particular version of Kubernetes. Question, yes?
Saurav, can you just go over the Acreno piece? Sort of, where did you say it fits into the on the compute side?
Yeah, what I was saying that we don't mandate that you have to use the Kubernetes version that we are using. It could be a different one as long as it's supported by the rest of the software. So you could take, if you remember Scott's slides from the first session about the software architecture, we had some platform software. We had a profile, which is SEBA, that gets launched on the platform software. And then finally, there's a workflow that sort of customizes the profile. The point is, all of this software stack can go right on, can go on top of the choices that we have made, okay? Or it could be an Acreno or some other blueprint, right? So as long as you ensure that the software works on top of the choices of operating system or Kubernetes or Kafka, we are good. You don't have to use the versions that we use in a release. Same thing goes for like the SDN controller. I've drawn this vertical line. Again, the point behind this is that you need an SDN controller. It doesn't necessarily have to be ONOS or the apps that we have written on there, as long as you ensure that the operation of the rest of the system works. Some people have said that, the choice of XOS or the choice of the monitoring that we have made, again, you may have your own versions of it, and that's fine too. It's modular that way. So the point behind showing you all this is that the three operators that have committed to taking SEBA into production next year, as DT, AT&T, and AT&T, they have different requirements, right? And these operators have made different choices, right? Some have gone with parts of the system, taken more, some have taken less, and so on and so forth. But the point is they've all agreed that there is a 60% of SEBA that is what we call a common core, okay? And in that common core, there are certain features and capabilities that apply to most, if not all of them, right? So they expect that in this common core, these features should be there. And they have, so that document that I have linked up there has complete details. You're seeing only a fraction of this document on this particular slide. But I do encourage you to go and look at the requirements for features, functionality, operational features, scale, and so on and so forth that we have come up with. This is the Tiger team slide. And we've been working on this to identify this common core, 60% of SEBA, and then we're going to put together. They have been working with the community to put together a surge of resources that will drive this common core into hardening and feature completeness and meet the requirements that we have on this document so that we can go into production next year. Okay, any questions? Yes?
So based on this feature matrix, it sounds like SEBA 3.0 has to come in place and productized, at least for the TT, by the end of this year.
Yeah, well, they would like the features, yes, by the end of this year. It's, our conclusion is that it's more likely that it's going to be Q1 of next year.
Okay, SEBA 3.0, you said targeting for the production?
No, not SEBA 3.0. I'm saying that 60% of SEBA, the common core, is targeted for production. Did I not make sense? SEBA has a lot of components. They are modular. Some things can be left out. The operators decided on the 60% of SEBA, which they call the common core, which they have targeted for production next year.
Do we have anybody from TT here?
Anyone from Turk Telecom? Don't see anyone.
Tomorrow we'll ask them.
Okay. Yes.
Is it feasible? Because the first, let's say, announcement from AT&T was Q1 2018 to tell something. Yes. And secondly,
Can you use the mic?
sorry. So, is this feasible? Because first announcement from AT&T was Q1 2018 to have some commercial deployment. And secondly, I believe that Water 2.0 is necessary condition to have this scalability and stability. And yet we see quite, let's say, optimistic dates here. And Water 2.0 is not yet here. So what is your comment on this?
So is it
timeline?
technically feasible? Sure it is. Is it going to be feasible in the time frame? Yes, with enough resources. So we're getting the resources into place. Regarding your comment about 2018, they did do a trial. Oh yes, we announced it at ONF Connect last year in December. They have live subscribers in their trial in, I think it was Dallas and Austin. I'm kind of forgetting, but you can go back and look at the videos of ONF Connect last year. So they did do the trial. It was a small scale trial. This one is was targeted to be bigger. But ultimately, AT&T needs to answer to AT&T questions posed to AT&T. I don't want to speak for them. But what I do know that these three operators have committed to trialing in production next year. And so all the effort has been in bringing together enough resources to meet these requirements. And so, that's all really I can say. So that's the work that's going to go in over the next 6 months.
And what happened with Telefonica?
With whom?
Telefonica.
They're not an ONF partner. I can't really talk about
Yes.
them. They're not involved in this work. This is ONF partner level discussions. Okay. So best to ask Telefonica personally. Okay, with that, I'd like to move over to talking about Volta 2.x, give you a brief idea about what's going on over there, and then the embedded BNG work. So Scott will take over.
Okay, so I'm going to spend just a few minutes talking about Volta 2.x. So at the time we released SEBA 2.0 alpha, Volta 2.x was not at feature parity yet. Basically, some of the features we were missing were the tech profiles, the bandwidth profiles, and some stability-related things. So we went ahead and released 2.0 alpha with Volta 1.7, while work on Volta 2.x continued. So the community is working extensively. We have a lot of people involved in the effort to stabilize the Volta 2.x code base. There's an entire brigade devoted to it, led by David Bainbridge. And if anyone is looking for work to do, we could always use additional people working on that effort. The current plan is to integrate Volta 2.x as soon as the feature parity and stability goals are reached. So there are a lot of changes in the 2.x code base. The first thing is that major portions of Volta 2.x were rewritten from Python to Golang. That includes the core, that includes the OpenOLT adapter, and there's ongoing work to migrate additional components over to Go. So with a language change certainly implies significant code rewrite. There is a new high availability model. So we have disaggregated what was before a fairly monolithic Volta and split it into a couple of parts. There is an API server, which is sort of a high availability front end, and then there are read-write cores and read-only cores, which implement the old core functionality of Volta. And there is an active-active scheme employed with this API server and these rewrite cores, so that if a core was to go down, you will get very fast failover to the remaining core that is up. And that is one of the key contributions of the new API server, is that fast failover. I believe we were given certain limit in milliseconds that this had to happen, and that led to some of the engineering choices there. So major architectural changes with this disaggregation. There's also a lot of communication-related changes. So for example, we have new formats for events and performance metrics. Rather than using JSON over Kafka, we're now using protobuf encoding over Kafka. So it's kind of a binary format now, but it is encoded in a much more efficient and performance-mindful manner. People have done a few studies and proven that the protobuf encoding is much quicker than the JSON encoding, both to serialize and to deserialize. So here is a picture of the architecture. So we still have an OpenFlow agent, and we still have a Volta CLI. So you kind of saw the CLI earlier in some of the hands-on portion. It's pretty much a similar CLI talking over gRPC. But then you get into here, and we have a lot of changes. So you now have the affinity router, also known as the API server. And it is a gRPC server / proxy. So it is going to route gRPC requests to the appropriate container. We have read-only cores, and the only thing the read-only cores talk to is a data store, which is in etcd. So read-only cores, you can send a request to any one of them. They're all identical. They can all serve that request. It's just round robin. We have read-write cores. The read-write cores will also talk to the data store, but they also talk to the adapters via a new Kafka adapter bus, which also uses gRPC encoded protobuf to talk to these adapters. There's also over here a separate Kafka alarm bus where alarms or performance metrics and stuff can be sent northbound. There's still adapters down here, but they're now speaking that new inter-adapter protocol. So there's also, implicit in this is a lot of containerization, whereas previously a lot of things were monolithic. Now the adapters are in their own containers, the cores are in their own containers, the API server's in its own container. Massive containerization and disaggregation of the old Volta core. So the core has been re-architected a bit. You can see we have the affinity router slash API server that's in its own container. This blue part here is the new Volta core. It has a GPI or a gRPC server. Beneath that is an API layer that handles the arbitration of which core in an active-active pair will actually service the request. So there's a little bit of a race when a new request comes in. Both cores will try to perform a lock to get access to that particular request. One of them will win and become the active. The other one will become the backup and kind of sit and wait to see if the primary times out. If primary times out, then it will take over for the primary. That's our fast failover. All requests get sent to both cores. We've got many of these components here came out of the old Volta, rewritten, of course, in Golang, but same sort of purpose. Then we have some new layering down here because we have that new inner adapter bus between the cores and the adapters. So there is a new library that is a proxy for this inner adapter communication, and then the inner adapter Kafka proxy, the sort of the Kafka-specific portion of that, talking to a Kafka bus. And I think the idea is that these layer here's, if people wanted to, they could change those out. It doesn't have to be gRPC encoded Kafka forever. You could easily change out this layer here because of the abstraction above it. You wouldn't have to modify all the above code. You only change as much as you need to. So it's very modular design, forward-looking. So there, as I mentioned before, there is a stabilization brigade. The stabilization brigade has already forked a stabilization fork where the stabilization work is taking place. It's called 2.1, so master, I think, has gone on to 2.2, where stabilization is at 2.1. New features are going into master. Bug fixes are going into the stabilization branch. And every time a bug is fixed in stabilization, that patch is also cherry-picked to master. But the idea is to keep feature work and stabilization work as separate as possible, so the new features are only going in to master. And we're also doing a lot of work on test frameworks, and the test framework work, it spans both the stabilization branch and master. So the same test infrastructure we developed for stabilization is automatically being used on master. And the current focus of the brigade is on developing the test infrastructure as well as fixing bugs, determining stabilization issues, and making Volta more stable. And we are at the start of this process. So we have a lot of people working on this. We have a brigade meeting, which I believe is early Tuesday mornings, and anyone interested can contact us and we will put you in touch with the brigade. And I think that is it for my, go ahead, Saurav. Yeah. Sure.
So the main goal is to optimize the structure, I guess. So that the structure will be faster, more scalable, and so on.
And high availability.
Yes, scalability. Do you have any KPI or goal? How many subscribers would you then reach with this structure in Volta? How much better would it be in numbers? How fast? How much faster?
It'll go from not scalable to scalable. That's as best as I can. I don't have the absolute numbers, but we were running into scalability issues at relatively low numbers before. And I think this redesign to the high availability, modularity, binary encoded buses, it's all intended to get stabilization or to get scalability where we need it, to the goal of 16,000 ONUs. On a pod. That's where we want to reach, and the belief is this design will get us there. It may get us beyond there. Hopefully. We will see.
Okay, so today you've seen that most of the main blocks of a central office in SEBA pod has been already SDNized. So for example, the OLT and the PON has been SDNized through Volta. Oh, sorry, I'm Daniele. I'm an intern in ONF, and I'm worked mainly in this, in what I will present today. So as I was saying, The SDN approach has been used in SEBA for SDNize the OLT and the PON network through Volta. It's been used for the aggregation network for, through Trellis and white box switches for SDNizing the aggregation network. But there's still a single piece that is the BNG that is still not SDNized. So it's a black box, a fundamental black box that is implemented in almost any network operator networks. BNG implements many functions. Some of them are operator specific, but many of them are common to all the operators, like, for example, subscriber tunnel termination, QINQ, or PPPoE, accounting, hierarchical QoS, low-for intercept, and so on. So this is SEBA today, the SEBA pod today, SEBA 2.0. We have open hardware, such as OLT and the aggregation switches, managed by open source software like ONOS, Volta, and NEB. But still, the BNG is external to the SEBA pod. So we asked ourselves, can we disaggregate and embed the BNG inside the SEBA pod? The approach that we want to use is the same that we used for the other blocks of our central office. So using an SDN approach to separate the BNG functionality, to disaggregate the BNG functionality inside a SEBA pod. So exploiting P4-based white box switches to implement the user plane and implement the control plane instead as an open source application running, for example, on ONOS. The plan that we have for BNG disaggregation in SEBA is separating the black box, disaggregating the black box in two main functionality, two main blocks. The user plane, identified as BNG-U, and the control plane, BNG-C. The user plane manages mainly the traffic, the data plane traffic of a subscriber, and can be implemented directly in Fabric in a SEBA pod using P4 and merchant silicon. The control plane instead can be implemented as a mix of application running on ONOS and also exploiting possibly external control plane services and softwares. Our initial focus has been dedicated on a PPPoE-based BNG because thanks to the Deutsche Telekom, we have an initial P4 implementation of a PPPoE-based BNG user plane that we integrated inside the Trellis Fabric, fabric.p4 specifically. So the proposal for the BNG-U is to use an approach of a functional distribution because it's very difficult to find a single device that can implement all the functionality of a user plane BNG on a single device, especially with open interfaces. So our idea is to exploit both the Barefoot Tofinos chips in the aggregation and service switch inside the Trellis Fabric, and the Broadcom Qumran chipset inside the OLT. That is because the Broadcom Qumran chipset has deeper buffers and can manage easily HQS, can implement easily HQS, while with the aggregation switch with the Barefoot Tofino, we can implement most of the functionality of the BNG-U, the blue box that you can see in this slide. That can be abstracted as a match action table, and so it's straightforward to use a P4 for describing such a pipeline. And then also using P4, we have P4 runtime interface and also using Stratum to manage the flow tables at runtime. So we have a common and easy to use interface for managing the state. So this is an enhanced SEBA with an SDN version BNG. In red, you can see the new blocks that we introduced. So we have the BNG control that is running on ONOS together with the Trellis application and all the other SEBA application. We have Stratum running on a P4 switch. So instead of using a Tomahawk-based switch, we can use a Tofino-based switch as the Fabric switch. So this allows to integrate another ONF project that is Stratum inside SEBA. So BNG-C app is running on ONOS. It can also work with external control plane software, like, for example, PPPoE server implementation already available, while the BNG-U will be functional distributed between the OLT and the Fabric switch. So we already implemented a proof of work that is actually demonstrated at ONF Connect. In this case, we implemented the BNGC as a relay application that is relaying packets that received from the subscriber PPPoE client, just control packets, to an external PPPoE server. The PPPoE server is a standard open source implementation available as a package on Ubuntu. The PPPoE server just manages the authentication, address assignment through IPCP, and the keep alive. While all the data plane traffic, so all the traffic generated by the user towards internet, for example, is managed completely inside the P4 switch. So completely inside the user plane, the user plane of the BNGC. So if you want to learn more and you're interested in knowing more, we have a demo in ONF Connect. You can visit our booth to see our demo. There's still some pieces that are missing. Mainly is an integration with the NEM to push events related to subscriber management and FCAP supports, and then a PPPoE-based workflow for TT and DT. Then also the BNGU pipeline has to be improved. For example, adding hierarchical QoS for the downstream traffic, supported service delivery protocols other than the PPPoE, like for example, IP over Ethernet with DHCP-based subscriber address assignment. And then there is still some feature in P4 that are missing. If you're willing to help, we're ready to implement it.
Is P4 technology a requirement, so precondition to implement virtual BNG inside, or not?
Let me answer that. So it is not a requirement, but like I was explaining to the gentleman before, it is a choice that we have made because we're in the business of putting out exemplar implementations, and for us we try as much as we can to use as much open source as we can to lower the bar for other people to try it. And so this functional distribution that we had seen in Daniela's slides, where we're implementing the BNG user plane partly in one chip and then partly in another chip. That's a choice that we have made. It's not necessarily the only choice. Other people can decide to do it on other chips or other devices, may not even want to functionally distribute it over two chips. That's one choice. Yet another choice could be that maybe you don't do it in hardware at all. Maybe you do it in SmartNICs on servers and do a vBNG, right? So there are other implementation choices, and we can't do all of them. We have made one choice, and that's what you saw on the slide today. We are at the end of the tutorial, so please feel free to ask any other questions if you don't mind hanging around to ask questions.